Like I said, this is going to be a beginner's guide to get started with Git. I'm going to assume you know a little bit about Git, a little bit about Linux or just how to use a terminal in general. So how you can change directories, how you can open up a terminal in a certain directory. This isn't going to be a step-by-step tutorial. So you're going to learn the areas that you're going to need to focus on when you're getting started. And it'll also give you the knowledge of what you'll need to look up when you get stuck, but it's not going to go through every individual step. So I'm going to go through when you're going to use Git, how you can get started, some of the everyday commands that you're going to use, and how you can work with others. And also, if you're already a little bit familiar with Git, I'm also going to go through some of the common problems that you might run into and that I hear a lot about. When you're going to use Git, how you can get started. So let's think about how we code. When we're coding, we're often just using a file, for example, a Python file, and we're just adding lines to the original file. So you can sort of think of this as you're constantly replacing the original file, and you're just editing that original file. So that works great for an individual person. But what happens if we introduce more than just one person? In that case, we could all work on the one file, but you're often going to run into cases where you can sort of think of this multiple as people working on the same place, and it gets really messy and hard to control. So one possible solution to that would be to have an original file. We have an original file. We make a copy of the file. For example, let's say Ada has made a copy of the file. And then Ada changes the file and creates a new revision. And then we replace the original file. In that case, it does help out with us not having lots of people working on the original file at once. But we run into the situation where what happens if Ada has made a change which we didn't like, and she's replaced the original file, and we actually need to go back? In this case, we wouldn't have a way to go back from the original. One solution is just to make copies of the file over and over again. Let's say every 10 minutes or like every so often. Whenever we save the file, we copy it and we store it as a new copy somewhere else. But what happens if we just forget to save? That's pretty common. You would just forget to save and you basically run into the same problem again. Or, and that's not even counting the problems with just storing lots of these files and managing all the different versions. So clearly there's a lot of problems that come when we introduce more than one person into editing code. It just doesn't scale, especially when we add more than one person. It becomes very difficult to scale the changes across lots of different files. So the solution is Git. When we want to track changes, or when we want to work with others without having to communicate every change, we should use Git. Git is a way of managing all those different changes, especially between different people in one central location. So that's the scenario of when and why you should be using Git. So now that you know why we use Git, let's go through how you can get started using Git. So like I mentioned at the start, I'm not going to go step by step through how you can install it because it depends on your operating system and your environment. Instead, I will point you towards Atlassian's helpful guide on how you can install Git. And actually, I would highly recommend for any Git resource that you have a look at the Atlassian stuff because it's very clearly written and works really well. I will point out some of the very important commands that you should focus on. Once you've installed Git, you need to run a couple of configuration commands, and this will get you started with Git. And you only need to run these once, but you do need to make sure that you run these. So the first two commands, git config -- global user.name and user.email, set information that Git uses to identify you. For example, my username is Gordon and my email is hello@gordon.com. So the only thing that you really need to be careful with here is that you need to actually make sure that you're comfortable with sharing this username and this email publicly. Because if you ever work on a public repository, or if you work on a public project, then this information is actually public. So make sure you pick an email and a username that you're comfortable sharing. Lastly, you'll also need to run this git config -- global core.editor command. And here I'm setting this editor to Vim. So what this command does is it allows us to basically set which editor that Git will use when it needs to make certain changes. So in my case, I like Vim because it's quite simple to use, but you can use any editor, including Nano, Emacs, whatever your choice is. Yeah. One other command that you'll need to run, which you don't actually need to understand at the moment because it kind of relates to some other stuff that we'll talk about, but it's more just a convention that's changed recently, so you need to set it, is git config -- global init.default branch, and then you should set it to main. So historically, this default branch has been called master. But now recently, a lot of the major players in the Git space have been changing the name to main. And if you're curious on why that's the case, then you can read this article from the Git mailing list. But you do need to run this command if you want to work with most of the Git tools now, although you will probably still see this master branch around a lot. All right. So Git was designed for the CLI, so it will make a lot more sense if you're using the CLI. However, if you do find that a GUI like Git Kraken or Git K works better for you, don't feel pressured to avoid it. I think personally, whatever workflow works best for you is what you should take. And you need to try to reduce the barrier to entry. So while using it via the CLI is definitely the best scenario, if you find a GUI better for you, then go for it. And also a side note for Windows, you're often better off using the default PowerShell or Windows subsystem for Linux shells instead of using Git Bash, which is the pre-installed terminal with Git for Windows, since it can be pretty confusing to switch between the two. So again, this is just advice, and if you do find that it works better for you to use Git Bash, then you should use that. But just a TLDR, use PowerShell or WSL over Git Bash where possible. All right, I'm going to go through how we can get started with Git and create a new project. So when you're in your working directory, you should open a terminal to start using Git. Like I said, Git is a CLI tool, so you'll need to use the CLI. You can run this command, git init, and this will create a .git folder underneath the working directory. This .git folder holds all the information that Git needs for that particular project. So this is a very important folder, although you probably won't actually modify anything inside it directly. You'll be only using Git commands. but you do need to make sure that this git.git folder gets generated. Yeah. So we can also call this working directory a local repository. So a local repository is basically how Git calls something that is a local copy of a Git project. So I'll refer to them as repositories now, which is just like the store that Git refers to. And this is your current working directory. I'll also discuss later on what a remote repository is. So now that we've gotten a working project, we actually need to do some stuff with it. So I'm going to go through the everyday commands, which you'll use if you start working anywhere at a software company that you'll basically use every day. So first off, I'm going to create some files. I'm going to create a README file, and I'm going to create a hello.py file. And this little U over here just means that it's a new file. And I'll explain exactly what that means later. But right now, I've just created this file, and I've created this file. And it has some text in it, which I've made. And then that's basically the contents of these files. So I haven't run any commands yet. I'm just creating some files. The very first command that you should learn is git status. This is a very important command, and you need to run this basically all the time before you're doing anything in Git. And it's just a quick way to check what is happening in your Git repository. When I run git status in this repository, this local repository, I will see that there are untracked files, readme.txt and hello.py. That's what this U is standing for, untracked. It means that Git hasn't yet seen these files before, so it doesn't know what it was previously. So it's just saying that we haven't seen these files before. That's what untracked means. And you can see them represented up here in the unstaged area. And just a little special note, untracked and unstaged are different, and I'll go through that in the next couple of slides. So now we have the files, and Git doesn't know about them. So how can we tell Git what the files are? We use this command git add. Git add, and then you pass in the path. So in this case, I want to track the README file. So I say git add readme.txt. So this is also called staging in Git. Staging is essentially a way of telling Git that these are the changes that I'm preparing to use, that I'm preparing to track. So please stage these files, these changes, for me to review in the next step. And that's all this git add command does. And you can see that right now I haven't staged my hello.py file, and it's still untracked and unstaged. And you can see the readme.txt isn't staging now. Now that I've staged this readme.txt file, I will do something called git commit. What a git commit does is essentially it's saying, I want to take a snapshot of all the changes that have been made. I want to snapshot everything that has changed that I have staged in staging, and I am now ready to compare this snapshot with previous snapshots. Since this is our very first time, there are no previous snapshots to compare, but I'll just run git commit, and then I'll pass in this -m flag, which is short for short message, and I'll add in a short message, add readme. And this is essentially telling Git to take a snapshot of all the changes that happened in staging, and it attaches this message, which tells us what has happened and why it has happened. So I've added the README file. And now this is permanently tracked by Git, and this is ready for changes to be made. So I'm going to go through briefly what makes a great commit. A great commit should always be related to one idea. So that's what they call atomic in Git. Basically, it should be indivisible and related to a single concept. One example is if I try to change a lot of different features at once, which often happens when you're not sure exactly what you need to be changing. And we'll get into how we can fix up our commits as well so that they're always atomic. But we should strive to keep it related to one single idea at a time. Secondly, we should explain what and why we're doing something in our commit messages. So if you're curious, you can read a bit more about that on this very helpful blog. But essentially what we want to try to avoid is we don't want to explain how we're doing something, but more about what we're doing and why we're doing it. So an example would be if I write a commit message that says, changed if statement to check greater or equals to 500. That doesn't actually really explain why we're changing the if statement to do that. Instead, if we wrote a commit message like check fix if statement not checking out of bounds, then that would make a lot more sense on why we need to do that sort of change. And it explains exactly to people who might be looking at this in the future why we are making these changes, because they will be able to read the code, but they might not be able to understand why you're doing something. So you can sort of think of this like writing a good comment on your code. And the third thing is you should try to keep them small. This isn't always possible, but in general, you should try to keep your commits as small as possible because it becomes very difficult to read if you don't. So sometimes we make a mistake and we accidentally commit something that we didn't mean to, or we committed something, but there was actually a bug in it and we needed to fix it. So that's what this git commit -- amend command is for. Basically, this works exactly the same way as a regular commit. But the only thing that's different is that instead of creating a new commit, you're editing the previous commit. So a couple of examples of when you want to do that is when you accidentally make a typo in your commit message, or we've missed a file and we forgot to stage a file previously, then we might want to edit the previous commit, and when we want to fix up the previous commit. So like I said, we should try to keep commits related to a single idea. So instead of adding all the fixes as in just like constantly adding fixes and being like, fix this, no, really fix this, no, really fix this, then we can just put it into the single commit, and then people can read through the commits more easily in the future. So now let's get to the real meat of Git and why it's actually a very powerful tool and why basically every team in the world uses it. When we're creating changes to a file that has been tracked, Git will actually know that individual lines in the file has been changed. So like I said, Git has already captured a snapshot of this file. So previously it was project name by @author. Now I have decided to change the file and remove this project name and replace it with the actual project name, Git Gud. And I haven't changed this hello.py file. So that's still untracked in this case. But I have now modified, which is this yellow M, I have now modified this file and I've changed it from this line into this line. And Git will know that this has changed. So to check what changes we've made, it's quite common to run this git diff command. So git diff will run the diff tool, if you're familiar from Linux, over all the files that have been staged. And we'll see all the changes that's been made. So you can see that nothing has changed in the original file, but all the changes that I'm making, I've removed this line and I've added this line. And those are making changes to a tracked file. In most editors that aren't just like plain text editors, you'll find that there are actually tools which you can use which help you do these changes via GUI. So it's quicker, or you can have more context on why things are happening. So this is VS Code, Visual Studio Code, which is one of the editors. And you can see that it's actually displaying these changes. For example, a modified file or an added file. So A for added, so it's been staged, or M for modified. And I can see exactly in the diff what has changed. You might need to install some extensions for you to get this depending on your editor, or it might just come by default. So it sort of becomes a big drag once you're working with more than 2 files to stage all the files like one by one via their path. So there's a command where you can run git add -a, capital A, and that will stage all the files that were previously unstaged, and it'll put them into staging. So you can see that the changes that I'm committing are readme.txt, which is basically the modified file. So note that I already have the snapshot file, the committed file from previously, but now I have the modified file as well in the readme.txt. So this is the changed file, and this is the one that I've already started tracking. And I'm also committing a new file, which is the hello.py file. And that's a quick way which you can stage all the files at once. So to avoid accidentally staging stuff that we don't want to track, for example, secrets or temporary files or binary files that can be regenerated, we use .gitignore. So .gitignore is a file which stores the path or patterns which shouldn't be tracked by Git. So it's a bad practice to store lots of big files or lots of binary files because Git doesn't really work well with binary files. It's mainly designed for text files. And because Git stores lots of snapshots, the repo, which is short for repository, can become very big, very fast if you're constantly storing these really big files. So I'm going to show you what a .gitignore file might look like for C. In this .gitignore file, which was made by GitHub, we can see that it's not storing some of these binary files. For example, object files or DLLs or exe files or the output files. That's because we should be able to easily regenerate these files later on. And right now, they're not very helpful for Git because they're sort of a temporary file, and we don't need to track those changes because a binary file is more likely to change a lot over time. And it's not very helpful for us to keep those changes. A question I get a lot is, why do we bother staging files at all? Why can't we just commit directly all the files? And that seems to be a very common practice among people in uni and even people in industry. is just committing all the files at once. So recall a good commit is related to a single idea. And I sort of mentioned this before, but we want to control exactly what to commit. And the only way we can keep everything related to a single idea is if we have that way of controlling what to commit. So that would be staging. And you might think that, oh, I can just make all the changes and they should all be related to a single idea. But when you're experimenting with your code, or like when you're trying to figure out exactly what a bug is, it can be really difficult to do that without changing lots of different things at once. So that's why we stage files, is so we can make sure our commits are always striving towards this best practice. And for an example of that, we made a mistake. We've added this hello.py file and this readme.txt file together with that git add -A command, which staged all the files. But they're not truly related to each other. So what happens when we've accidentally staged the file that we didn't want to stage? We can use this git reset command. So you'll need to run git reset head and then the path. So I'll get back to this head thing very quickly. But for example, if I run git reset head readme.txt, I will unstage this file, this readme.txt file. And that means I can keep this commit solely related to why I'm changing hello.py, or adding hello.py in this case. So what's head? And why is it on all caps? And what is this mysterious head thing? So you'll run across this actually quite often in Git. So if you run the git log command, which essentially shows us a log of all the previous commits, you'll see a list of all the commits. And I'm adding these flags --decorate --1line --graph because it makes the log a lot easier to read. And I would suggest using this command as well. Or you can just run git log and you'll see the same thing, just a lot more information with it. So we can see that we have this command, this commit that I made, add readme, and then I have another commit, add greeting, and I have this third commit, update project name. And you can see this head thing. All this head thing does is it essentially points to the branch that I'm currently working on. So I very briefly touched upon this in our getting started part, but that's now called main and used to be called master. And I'll explain exactly what a branch is as well. But essentially, it's just pointing to where we're currently sitting at. And we can actually move this head around to wherever we want. It is basically just pointing out where we are. And then we have the untracked changes right above that. This doesn't show in the git log, but you know it's there. It's just the commit, the non-committed files that haven't, the uncommitted files beyond that. So there's also this weird combination of letters and numbers. What this is a hash. It's actually a SHA-1 hash. You don't need to know that, but it is basically how Git will identify a commit. And it is important to know that these are the IDs for the commit. So that's what you need to remember. When you see something like this in Git, it's probably one of the commit IDs. Let's visualize how Git basically structures its things. So like I said, these little dots represent a snapshot in time of the repository. And we have these commit IDs, which are linked to these snapshots. These commit IDs basically identify these snapshots. So we got this snapshot, which is a commit with this commit ID, and then we have this commit, and then we have the uncommitted changes. So you can see how that parallels this log. And this is a very common way of representing our Git. And this is often called a Git tree. And that's why we call this very first commit the root commit, because it is the root of the tree. It doesn't really look much like a tree since it's kind of just a line at the moment, but you can see that there's the head and it's pointing to this commit. Note that it's pointing to this commit, and then it isn't this commit. It's just pointing there. And then the main branch is also pointing here. So you can kind of see why we call this the main branch. It seems to be the main line of commits. So this main branch points here. This head is pointing to main, and this commit ID identifies this commit. So I'm going to get back to why we call it a tree quite shortly, but let's talk very quickly. Let's not talk very quickly, but let's talk about how we can work with other people, which is what most people are using Git for. So like I said before, there's the concept of a local repository, which is something that's on your personal computer, is something that you are personally keeping local. And then there's the concept of a remote. A remote is essentially just a repository, but it's stored in a server somewhere. So some very common ones are GitHub, Bitbucket, and GitLab. And these are all providers who provide a service for storing a remote. And actually, you could create your own if you so desired, but it's not very common. Most people will either use GitHub, Bitbucket, or GitLab. So for example, in GitHub, I have this, I pulled up this remote repository for emoji code. And you can see that it has all the files, and this is one of the snapshots. And you can see that it's on the master branch. Like I said before, master has been used for a very long time, so you'll still see this very often. And the new way of calling these branches is now main. But they refer to the same thing. And actually, they can be named anything you want. It's just conventional that it's either be called master or be called main. And you can see that there's been a lot of commits to this master branch. So this is an example of a remote repository. When we're in a remote repository, sometimes we want to be able to start working on it. So for example, if in a team project, you'll probably want to be able to pull down the code and start working on it, and then push the code changes back up. And the way we do that is called cloning. So if you see over here in our remote repository, there's this little code button in GitHub, and it's quite similar in Bitbucket and GitLab. When you click it, you'll get the option to clone these repositories. And there's a couple options here. There's HTTPS, which is essentially just referring to the way that Git Hub is trying to authenticate you to make sure that you have the permissions to clone this repository. And there's also SSH, which is the same thing, but via SSH. And if you're more comfortable, or if you've already set up SSH before, then you should probably use SSH. It's just a lot faster to work with than using HTTPS. But don't feel bad for using HTTPS. It's still a perfectly valid way of using Git. It's just faster if you use SSH generally. And there's also GitHub CLI, which is a new tool that GitHub has released. I'm not going to go into it, but just know that's an option as well. So I've said clone a couple of times. What does a clone mean? When I'm cloning a repository, all I'm doing is I'm basically asking the server for a copy of that repository, and then I'm pulling it into my working directory. So git clone URL and then the path. So this URL is the same as this URL. And I want to basically clone that URL into whatever path I desire. So if you want it to create a new folder, then you omit this dot, which just means current working directory, and then it will create a new folder. Or if you want to just clone directly into your working directory, then you include this dot, which means that it will unpack directly into your working directory. And like I said, this basically just makes a clone or copy of what the remote server has in your local repository. So now we have a local repository, and now we have a remote repository. To synchronize between the two repositories, we have two commands, git pull and git push. Like it sort of implies, git pull means that we're pulling from the remote repository, and git push means that we're pushing to the remote repository. And what are we pulling? What are we pushing? I'll explain that quite shortly in a diagram. And I'll also get back to this command, which will make more sense once I show you the next slide. So git pull. Let's say we have a remote branch, which is by default called origin. All remotes are typically called origin by default, and that's the default in Git. So that's why it's called origin. And then we have this /main, which means we're talking about the main branch. So let's say the remote has had a change. This is what we've pulled before. And then it's changed once and it's changed twice. So what is a git pull doing? It's essentially pulling down those changes and then making sure that we're synchronized on our local repository with our remote repository. So that's pulling the changes. So these are commits, remember? These commits, and we're pulling them down into our local repository. And that's what we're doing here with a git pull. Alternatively, we can use a git push. So when we're trying to update the remote, we've made changes locally, then we git push to push these commits back up into the remote repository. It's always good practice before running a git push to run a git pull, and that makes sure that you're not accidentally trying to change something in the remote repository without having pulled down all the changes previously. So this is one of the commands which is kind of annoying about Git, but you just have to know, is when we're pushing a branch for the very first time, we have to add this -u and then the name of the remote. So in this case, it'll typically be origin, and then the name of the branch, so main in our case. So this command essentially tells Git that we want to track this branch, this local branch, to this remote branch. And that makes sure that when we're pulling, we're only updating this branch when we're pulling from this branch. Hopefully that's not too confusing, but essentially it just links these two branches together so that other branches, which I'll get to shortly, don't affect other branches. All right. So I've talked a lot about this main branch, and we can make changes to it, and then we can push it up or we can pull it down. But if you recall, in our very beginning, one of the workflows was to make a copy, change it, and then replace the original. And we want to try to avoid replacing this original as much as possible, because it becomes a problem if we replace the original a lot, because it's very hard to track, like I mentioned before. So that's why there is a branching methodology. So the branching methodology essentially replicates this idea of make a copy, change it, place the original. So when we use git checkout -b greetings, we create a new branch. I'll visualize what that looks like, but when I use git checkout -b greetings, I'm moving all my untracked files into this new branch. So you can sort of think of that as we have the root commit here, we have a intermediary commit, and then we have this ancestor commit. Sorry, this should be child. We have a child commit. So these lines that I'm using here aren't actually representative of time. They're representative of inheritance. So this child commit inherits from this parent commit, and this parent commit inherits from this grandparent commit. So you can sort of think of this as an inheritance. Or like a tree, it is a branch on each way. And you can see that the head is pointing to greetings now, and greetings is pointing to this commit. Main is still pointing to this commit, but we just need to note that head is pointing to greetings now because I have run this git checkout command. And this greetings branch still is pointing at this current commit. If I was to make a new commit, for example, git commit -- allow empty, which just makes a empty commit, so one that doesn't have any changes in it, just for demo purposes, we can see that the main branch is still pointing at this A17 commit, but the head has moved along with the greetings branch. So we now have this 1B1 command, 1B1 commit. And you can see that it's sort of a branch off this parent commit. So this is a new child commit from this parent commit. I've omitted the root commit for clarity purposes, but basically we're just making a branch off. And you can see that the head is still pointing at greetings. So that's why when we make a commit, it's on the greetings branch and not the main branch. What happens if I do want to make a commit on the main branch? We use that git checkout command again, but this time we don't use -b. -b is for creating a new branch, but we just want to move back. So when we run git checkout main, we're pointing this head back at the main branch. Back at this main branch. And this main branch will essentially be where we're now working off of. So what's git checkout actually doing? When we use git checkout -b, like I mentioned, we're creating a new branch and we called it greetings. When we run git checkout and then a branch name, we're moving our head to point towards this, this branch name. And when we run git checkout and then a commit ID, we can move head to point at a commit. And in that particular case, it's called a detached head state because it's no longer pointing at a branch. It's pointing at a certain commit. And what this moving around of head is doing is it's actually going back to this particular snapshot. So all your files, all the changes from here are now back. Sorry, all the files in your working directory, your local repository, will now reflect this snapshot, not this snapshot. So I've git checked out main. So now I am back on the main branch and all my files look like what they were previously. If I run git commit again, but now I'm on the main branch, you can see that I've created this new commit over here and the head has moved along. There's still this greetings commit and then there's still these parent commits. And you can see sort of why we call it a tree now. We're forming this tree-like structure. The one difference from a tree is that we want these changes to be replaced back in the original. If you remember from our diagram, if these changes never get replaced back in the original, then the people on the main branch won't be able to see the changes. So just quickly before that, we're going to go through command git branch. This is just a way to see all of our branches. So it'll show you that the main branch is there and it'll show you that the grading branch exists. So to merge back to the original, to replace that original branch, we do something called a git merge. So to git merge, we git checkout back to the base branch. So that's the branch you want to merge into. In our case, it would be main. And then you run git merge and then the branch that you want to merge. So in that case, it would be greetings. So when we run git merge greetings, we essentially merge all the changes that have been happening over here back into here. So what happens if the base branch has changed? If there's been some conflicting change in here that conflicts with this change. So I'll represent this commit that has had a change as orange and this as a teal sort of green color. And you can see we're trying to merge back into here to create a new commit. This is called a merge commit because we're merging two branches. So let's say in the main branch, we've made a change from the original and we've changed the name to guide to Git. And in the greetings branch, we've made a change and we've changed the name to Git Good. So you can see that these changes are both changing the same line. So this is pretty common when people are making changes in a team. When someone makes a change in and merges a change before you, and now you have to make sure that your change isn't overriding their change. So one possible way might be to just combine the changes. But in most cases, that doesn't really make sense. For example, if someone fixes a bug in a particular way and then you fix the bug, you don't want to duplicate that code. So that doesn't really make sense. Instead, Git will do something called a merge conflict. And this is pretty much the bane of most people who use Git, especially uni students. But they're actually not that bad. And they can be pretty easily resolved if you know what you're doing, which you will by the end of this. So when we have a merge conflict, what will happen is when there's been one change in the base branch and one change in the branch that we're comparing to, you'll get this weird, funny thing where it goes lots of less thans. Sorry. You'll have lots of arrows and then you'll have lots of arrows over here. And this will be head and this will be greetings and you have some equal signs. And yeah, it doesn't really make that much sense. So remember, head is currently pointing to main. So these are basically the same thing at the moment. And you can see that this is the change that's been made by main. And this has been the change that's been made by greetings. So what you need to do to manually resolve a merge conflict is to remove all of these funny things and you basically change the file to how you expect it to be. So if you want it to be only this change, then you would just remove everything and just leave this line in. And that would be basically fixing the merge conflict by only allowing the compare branch changes in. Alternatively, if you remove everything under this and you remove this line, then you're allowing all the main line changes in. You can also, if you think that the changes won't be problematic if you insert both of them, then you can just remove this equal sign and you can remove these other lines, and then you can accept both changes in. And that's another way to resolve a merge conflict. So you can see that in this case, I wanted this title. So I've just removed everything else and I've just had this. And this is now a resolved merge conflict. And to tell Git that we're ready to resolve, we need to run some certain commands. So like usual, we run git status to see what's happening. And we see that both the base branch and the branch we're merging in has modified this readme.txt file. So all we do is we use our regular method of git add, and we add this, we start staging this readme file, and then we git commit, and we add in a commit message on why we fixed the merge conflict. So you can see that this is now the new merge commit, and it has this message fixed titled conflict. Real quickly again, most editors will allow you to give you a GUI way of doing this. So accept current change means that I only want the stuff that is in the main line. Accept incoming change is I want everything that's coming in from the branch I want to merge in. Accept both is accepting both. And that's basically a different way of doing it instead of manually editing it. Depends on your editor. You should know the manual way of editing just in case as well. So seems good. We run git merge. We merge in our branch, and then we git push our branch out. So we're pushing out this main branch now. So that sounds suspiciously like we're overwriting the original copy. So like I mentioned before, that can be a problem because it's really hard to see when we should be replacing the original versus when someone has accidentally replaced the original. So that's why there is a concept called pull requests. So pull requests isn't actually a Git concept. This is a concept that has been made by those remote Git services, for example, GitHub, Bitbucket, and GitLab. And this pull request thing is essentially just a wrapper on top of Git merge, which has a review process. So people can see what's being merged before they actually merge it into the mainline. So there are a couple cases where you might want to do it is like when you're reviewing changes to original or when you're making approvals. So I will now quickly demo what a pull request would look like. So you can see that I've pre-prepared a repository here, which just has a simple README file. And I've also prepared a branch already, which has the changes. So in GitHub, what I would do is I would go to this pull requests tab. I'll create new pull request. And then you see this base branch. I want to merge into main. So this is my base branch. And I want to merge the title branch in. And this is something that you should do pretty commonly, so pretty often. So this is a pretty important note to pay attention to. So you can see down here what change I made. So you can see that by default, it's just this Git-Good thing, but I want it to be all capitalized. And it's a very simple change. And you can see I've written a commit message. And this is the change again. So when we're creating a pull request, all we're doing is we're adding extra information on top to explain why we should be making a change. So sort of like those commit messages, we should, what I personally like doing is I like writing changes, change reason, and any additional comments. And this is just like a markdown thing. So you can write it in text, or if you know markdown, then you can use markdown syntax. So some of the changes might be changed to title. And the reason why is because default title was wrong. And then for my comments, I often include something like the ticket. For example, if I'm working in a big company, we'll have a way of tracking all of these changes. So they're called tickets. And I'll have something like, for example, if I'm using Jira, I'll have Jira and then the ticket number. And that will make sure that other team members can refer to that ticket if they're wondering exactly all the changes and the status and etc. So you can see this is a simple pull request. So again, just to sum up, I'm making a request to merge in this title branch into the mainline branch. And this mainline branch is what most people would refer to as the production copy or the production code. So generally, you don't want to make changes to it before it's been reviewed. So you can add reviewers up to here, and you can assign yourself, and then you can add labels and so forth. The most important one would be reviewers. There are no reviewers in this repository, but for example, you would normally tag other people in your team to review your changes. So I can create the pull request, and you can see that it's just doing some stuff. You can see all the commits, and the very important tab is files changed, where you can review all the changes. So if you are a person reviewing a pull request, then you would approve it or you would request changes. As I'm the one who created the pull request, I can't do that, but I can also add comments on, for example, the line, and I could be like, oh, so why was this changed? So why was this changed? This changed, for example, as part of a review process. So that could be one way where we could review code. So that's a pull request. And this is a very important concept, and you'll almost certainly run into it if you're working at a software company. All right. So thanks for sticking around for so long. I'm going to very quickly go through some common problems. I am not going to go through step by step how you fix these problems, but I'll kind of give you some places to start to research. There are lots of different variants of the problem, so you need to research your own specific problem and come to the conclusion of what to do. But I'll give you a good starting place for some very common problems that people run into. Okay, the very first one is merge conflicts when you pull. When you run git pull, it's actually doing two things. It's running a git fetch and it's running a git merge. So a git fetch is essentially pulling down all the information, but it's not including it into your branch yet. It's just simply pulling down that information from the remote. A git pull will also include a git merge command, which is why you'll get merge conflicts, because if you're pulling down something that has changed in the remote, then sometimes that will conflict with the changes that you've made locally. So you would resolve this in exactly the same way as a normal merge conflict, which I've already explained. Another common one is if you're checking out between branches, you'll sometimes have made some changes that haven't been tracked yet. So Git will not let you do this because, like I said before, when you're checking out between a branch, you're actually replacing all the files in the repository with the previous snapshot or the future snapshot. So if you have untracked changes, Git doesn't know what to do with those. So it'll ask you to commit them. If you don't want to commit them right away, you can also use the git stash command, which is essentially a way of storing the changes temporarily. And then when you're ready to reapply the changes, you can use git stash pop to pop the changes off the top and reapply them back onto the branch. And that's a quick way to work around if you made some changes, but you need to check out back to a different branch. That's a quick way to work around that. Another very common one is not abiding by the git commit principles, which is very common and happens to basically everyone, especially people who are like trying to figure out something, like they're trying to debug something. Very, very common. And you'll end up with all these fixed commits, like fix this, oh no, really fix this, I'll fix this other thing which is causing a problem. And you have all these commits which are sort of all related, but they're not really like useful. So if you catch it right away, you might use that git commit -- amend command that I referred to you before. But if in the case where you've discovered that the change has happened a lot later, then there's another very powerful command called git rebase. So that's git rebase. I'm not going to go into the command. It's extremely powerful, but it probably deserves its own talk because it is very complex. So do your own research on it. It is a very powerful command, and you can use it to basically fix up all of these mistakes that you've made when you're writing a commit. And finally, if you made a really, really big oopsie, like you've accidentally overwrote something that you didn't really want to do, or you've run a git reset dash dash hard command because you read it on Stack Overflow, but like you didn't really mean to delete all your files, then there is one saving grace in Git, which is git reflog. Again, it's a very complex tool, so I'm not going to go into it, but it essentially lets you step back the changes that you made previously. And for your reference, here are some of the commands. For example, git commit dash dash amend, git commit dash dash fix up, which I won't explain, git reset dash dash soft dash dash hard, git rebase, and git reflog. You can research some of these commands yourself if you're curious. But yeah, that will be basically it. And the one last thing that I want to explain is when you see someone approve changes and they have this LGTM thing, this means looks good to me. And you'll see this a lot. And this is what this LGTM means, basically. So now we're going to have some questions. If there are any questions, otherwise, please provide feedback. Workshops would really find it helpful, and they're really great. So please provide feedback on this talk.
Yep, Gordon, we had a question from Pieface. He wanted to ask, how do we change the name of branches or delete branches?
Okay, cool. So to change the name of a branch, you need to check out to the branch first, and then you use git branch -m, and then your new branch name. So that's how you change the branch name. And if you want to delete a branch, then you use git branch -lowercase d, and then the branch name that you want to delete. In the case that you've made changes that you haven't merged, Git won't let you delete the branch to accidentally avoid you deleting stuff that you didn't want to delete. But if you're really sure, then you can change that lowercase d into a capital D, and then that will force delete the branch. But you can check this all out either on the Atlassian site, which is a very good summary of it, or you can look directly at the man pages for Git.
Yep, I think that should be all the questions we have for today. Yeah, once
Awesome.
again, we're really looking to improve, always continuously improve, so it'd be really helpful if you guys fill out the feedback. And I think there's no more last minute questions, so I want to once again give a really big thank you to Gordon for presenting to this today. And also thanks you guys for coming up and turning up. Yeah, thank you.